Accelerated Algebra 2, start up here. Hey, this is notes for worksheet 4B. So let's see how we do with this. Make sure you're taking all the notes down on the sheet of paper, packet of paper I gave you for notes. We're going to be dealing with a little bit of functional notation. So we're going to be going with this 3x. So I'm going to blow f at -1. So it's f at -1. That gives me -3 for an answer. This one's going to be f at star. So I'm going to wind up with, let's pretend I can draw a good star. And that's a star. Those are supposed to be the same. F at 1, I have 3 times 1, which comes out to just 3. And then f at x plus 5, that's 3. And then x plus 5, you should probably distribute over the parentheses at that point. So you get that. Okay, very simple. Okay, so input is the x. This is the input. Output is what's taking place right here. That's what we get as a result when we plug something in. So our input on this one is x plus 1. If I plug that in, I get this. I replace the x with x plus 1. Again, distribute over the parentheses. Wind up with that. So there's my output. My input was x plus 1. My output was 5x plus 5. And then take a look at this one. What do we really do with this one? Am I affecting the input at all? No. This is just staying the same, but this is saying, hey, at the very end, we're going to subtract 5. So I'm going to take the 5x that I knew, and I'm going to subtract 5 from it. I can't combine like terms, so that problem is now done. More on that page? Yep, there was. Write each set of inputs and outputs as ordered pairs. So the very first problem, we would have had x plus 1, comma, 5x plus 5. This and this. And then the second one, we're going to have f at x minus 5. Oops, that's not a parenthesis, sorry. Comma, 5x minus 5. Cool. Moving on. So let's think about f at x. Remember, that's the same thing as y. It's just functional notation. Where's the x? Circle it. Okay, well, we'll follow along. We'll circle the x. It's right there. Found it. So if there's a change to the x values in the functions, it will look like something a little bit different. Let's see. Is there anything down below that we're going to go to? Look like something in the function. Actually, I think I'm going to be an erase. Is there anything to erase here? We're going to pull out. So if there's something that's going to change in the x values, that means that here is going to change in the functional notation. So this is the part that's going to change. We're going to change the x at all. Or the input. Input transformations in a functional notation. So these stars, I'm going to pull these out. I'm sorry, you can't pull them out on your paper. You actually have to write it in. So they'll always be inside the parentheses of f at x happening to the x. And input or x transformations in functional notation will always change the x with the opposite operation. So if you're grouped in math, if something's in parentheses, it will do the opposite of what you would think. If it was x minus 5, that actually means that it would move 5 to the right if it was minus 5. If it was x plus 5, you'd move 5 to the left if it was inside the parentheses. What about y transformations? Where is the y? This whole thing is the y now. It's not just the inside. So if there's a change in y values, the function will look like, it's going to shift it up or down. So let's look what this does as we progress on. I have a good answer for that right there. So output or y transformations in a function notation will always be outside of f of x, so happening in front. So let's go back to that last slide. So if we're going to do a change in the y, it's going to be like f at x plus or minus some other number or some other function. Okay, rules for transformations. So this is going to go left 2. Actually, take it back. It's going to go right 2. I told you that. I made a mistake. Because it's a subtraction, it's going to move right or left. And because it's a -2, it's going to go to the right. This one is going to go to the left. 3. So right, hashtag, left, hashtag. I know that as the number sign, but I know hashtag is the cooler way of saying that these days. Okay, so these transformations are vertical transformations. So this is going to move it up or down. So this is going to go down 2. So that stays with the same. This goes up 3. This actually does a couple of things. Okay, it's going to have a vertical stretch. So it's going to get skinnier as a graph in the vertical direction. Okay, but the negative out front, the negative is going to flip over the x-axis. That's a little different. We'll explore those in a little bit. All right, so down, hashtag, up, hashtag, stretch, hashtag, and then we'd say could flip over x-axis if negative. Sound okay? And again, if you have any questions on this, I'm happy to answer them while we're in class, okay? All right, so let's use this table to do a few of the transformations. So let's make a t-table of the significant points. So I have a good point here, good point here, good point here, and a good point here, and even a good point here. So let's label those in a t-table. I'm going to make it f of x. Remember, that's the same thing as y. So I have -8, -6, -4, -2, and 0. With the -8, I have a 0 in the y direction. With the -6, I have a 3 in the y direction. At the -4, I have a 0. At the -2, I have a 2. And at the 0, I also have a 2. Sound good? Ooh, so now we want to graph this. So we have to think about what's this going to do. This is going to move all x values right 5. Okay? So let's do that. We'll do it in red. Okay? We'll take care of this in red. So everything's moving 5. So I'm going to count 5 over. I'm going to go 1, 2, 3, 4, 5. I'm going to put a dot. From here, I'm going to count over 5. 1, 2, 3, 4, 5. And from here, I'm going to count over 5. 1, 2, 3, 4, 5. From here, I'm going to count 5. 1, 2, 3, 4, 5. And from here, I'm going to count over 5. 1, 2, 3, 4, 5. So this picture would look something like this. That would be what our picture would look like if I could draw really well. But it just shifted the whole thing to the right 5 units. It didn't really change the shape at all. It just moved. What about a negative out in front of f at x? Does it affect the x or does it affect the y? How does it affect the variable? Let's explore this a little bit. It's not going to mess with the variable at all. But we're going to do the opposite to the function. Meaning I'm going to change all of the signs with the function. Okay? What about the transformations like this? Ooh, this does the opposite to the x values. So if you plugged in 2, that means that you're going to substitute -2 throughout the problem. If you plugged in -5, you're going to plug the 5 in everything throughout. So again, let's take a look at this. We want to graph this, but let's go with our points. So it looks like I have 0, 0. I have 2, and then I have a 4. And then I have a 0 and a 4. Take that back. I made a little error right here. I just flipped it over. I'm sorry. That's going to be a 4, and that's going to be a 0. And then my last point is going to be 6, 2. Okay, so let's think about what everything's going to do to this problem. Okay, this is going to go up 5. So all of my y component, so I'm going to add 5 to it. But then the negative out front is going to flip or make it opposite value. Okay, so let's do this slowly. I'll do this in green. Okay, we're going to go up 5, so we're going to go, this is going to take me up to 5, but I'm going to make it negative. Okay, if I add 5 to this, if I add 5 to the 4, I get to 9, so that's going to be negative 9. If I add 5 to 0, I get to 5. That'll be a negative at the end. And I'm going to add 5 to 2 to I get 7. I'm going to make that a negative. So now let's plot the points 0, comma, negative 5. So 0, negative 5 is down here. Okay. 2, negative 9. 2, negative 9 is like down here. 4, negative 5. 4, negative 5, that's here. And 6, negative 7 is down here. So this is going to be upside down, go in the order that you graphed it. So take a look at our graph. It's the same graph, it's kind of just like a flip over and a shift in the vertical direction. And if you have any questions, I'm happy to go over that. So I think that's all I have for you all today. And take care of one another. Have a great day. Thank you very much. Bye-bye.